Let x1, x2 be two independent variables. Define t1 as x1 plus 2x2 as statistic for theta in Bernoulli theta distribution, where theta is in between 0 and 1. And t2 is x1 plus 2x2 as statistic for lambda in Poisson lambda distribution, where lambda is greater than 0. Then which of the following statements are correct? So we were given that x1 comma x2. So in the first case, x1 comma x2 follows Bernoulli theta. So that means the joint PMF f of x1 comma x2 given theta is nothing but theta to the power x1 plus x2 into 1 minus theta whole to the power 2 minus x1 plus x2. So now like if we list the possible values x1, x2 and t1, which is x1 plus 2x2. So when this is 0, 0, 0, this is also 0. When it is 1, 0, this is 1. And when it is 0, 1, it is 2. And when it is 1 and 1, so it is 3. So we can notice that each value of t1 corresponds to exactly one pair of x1 comma x2. So that means there is a one-on-one mapping between x1, x2 and t1. So therefore, knowing t1 tells us the exact sample. So therefore, if we notice that f of x1 comma x2 given theta is equals to, it can be written as z of t1 comma theta into h of x1 comma x2. So therefore, t1 is sufficient for theta. So that's for the first one. Whereas for the second one, like we have x1 comma x2 follows Poisson with parameter lambda. So if we find the joint PMF, f of x1 comma x2 given lambda is e to the power minus 2 lambda, lambda to the power x1 plus x2 by x1 factorial into x2 factorial. So the minimum sufficient statistic for Poisson sample is nothing but x1 plus x2. This is the minimum sufficient statistic for Poisson sample. So if we examine t2, let's say x1 plus 2x2, so we can notice that if x1 is, let's say, 2 and x2 is 0, so we have t2 as 2 and x1 plus x2 as 1. Whereas if x1 is 0 and x2 is 1, so then also t2 is 2 but x1 plus x2 is, x1 plus x2 here is 2 but x1 plus x2 in the second case is 1. So the same t2 is corresponding to different x1 plus x2, right? Same t2 but different x1 plus x2. The likelihood depends on x1 plus x2, not t2. So that means like we can't really factor the likelihood only through t2. So therefore we can say that t2 is not sufficient for lambda. So therefore t1 is sufficient, t2 is not sufficient for lambda. So therefore option B is the correct answer.